I have picked it from leetcode. So what the problem statement is, we have to build the H2O molecules. So in short, what it says there are two kinds of thread. Your oxygen and hydrogen. Your goal is to group these threads to form molecules. So in short, there will be this kind of threads, for example, H thread or O thread, and there will be many, for example, H, 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 O, O, H, O, H, O, H. So there can be two kind of thread. Let's suppose these are all threads and they all will be calling these functions. So hydrogen thread will be calling this function and oxygen thread will be calling this function. And when they call, so eventually they are going to call this. But what the problem statement is, that for example, if one thread has called this method, then it should wait until it has one more hydrogen and oxygen thread. So in short, until we have H2O, so these threads should wait. For example, let's suppose we have H, H, then H, H, then O. So these four threads will wait here and then O will come. So the moment O comes, so these two threads will be released, not all. Only H2O will be released. So we will have this released from here. Let's cut it out. And this released from here. Okay. Now we have, so let's start from beginning. Okay. Yeah. So let's suppose first this H comes, so it will wait here. Then this H will come, then it will still wait here because H2O is not complete. Then this H will come, then another H will come, so they all will be waiting there. So the moment this O arrives here, so H2, H and O will be released. So H, H and O will be released. So these two will be released and this will also be released, and then these two H will be waiting, and then another O will arrive, and then again this H2O will be released, and then this H will come, this will wait, this O will come, this will wait, and this H will come, then H2O will be formed, and these two H will execute this and one O will execute this. So in short, this line and this line should be called only when we have combination of two H and O. Okay. If it is not formed, then thread should wait above it. Okay. So I have copy pasted it here in my Eclipse. Okay. So what we need to here is, so first thing we need to do is we want to execute this two times. I mean, two thread will need to wait here and one thread will need to wait here. So what we can use is we can use cyclic variable. So let me create a cyclic variable. Let's initialize it here. It is good to initialize it in the, okay, what is shortcut for import? In the constructor, because in leetcode, in these type of platform, they run many test cases. So it is good to reinitialize them. Barrier equals to new cyclic. Three. Okay. And what do we want to do is we want to await here. What it is showing sound with try catch. Okay, that's okay. Let's do Control F1 extract to method await. Okay, let's move it to at the end. Yeah, let's remove this. Okay, and we need to put this here also. So what this will do is, until 3 threads come at this point or this point, it won't move forward. But there is one problem with this approach is, for example, this approach will fail for case when, let's suppose, uh, here one hydrogen thread has arrived and here 2 oxygen threads arrived. Then also this barrier will be broken. So for example, this will work for this case, but this will also work for this case, because there will be 1 hydrogen thread waiting here, and let's suppose 2 hydrogen threads are waiting, oxygen threads are waiting here, then this barrier will be broken. So what we need to make sure is that this works only for H2O case and not HO2 case. So to handle that, what we can do is, so we can use semaphore here. So what semaphore does is, if we have put some semaphore at any point with some initialized value, for example 2, then only 2 threads can pass through that certain point. For example, if I have put semaphore 2 here, then until 2 threads arrive here, they will all wait here. Sorry, that is opposite what I have said. So semaphore 2, what semaphore means is that if more than 2 threads arrive at this point, so it will allow only 2 threads to pass through it. So for example, if I have enclosed this block with semaphore 2 dot await and release, so only 2 threads can access this block, other will wait outside. So once any thread actually exits it, then only other thread can enter into this block. So for example, you have some DB connection and you want that no more than 10 clients should be able to access that DB. So what you will do is, you will before creating a DB connection, you will acquire semaphore and you will initialize semaphore with 10. And once you create a connection, you will acquire it, and once you release the connection, you will release it. So that will make sure that at any point only 10 clients are able to access DB connection, rest all wait. So basically what we need to do is, we will enclose this with semaphore so that only 2 hydrogen atoms can enter here at the same time, and we will enclose this with 1 oxygen. So what will happen is, here 2 hydrogen will be able to enter and then await here, and here 1 oxygen atom will be enter this block and then will wait here. Okay, so let's create now 2 semaphores. Semaphore, let's give it name hydrogen. Okay, now let's initialize that. Semaphore hydrogen is equal to new semaphore, and we want to give it permit 2 because 2 hydrogen should be able to pass through that point at any given time. And similarly, we want to initialize semaphore of oxygen with 1. Okay, now what we will do is, let's put semaphore hydrogen dot acquire, and here we will do semaphore hydrogen dot release, and similarly here we will do dot acquire, and here we will do semaphore oxygen dot release. So basically what will happen is, let's suppose a lot of hydrogen threads call this. So let's suppose they all arrive like H. So only 2 will pass through this point, and then they will be waiting at the cyclic barrier. Okay, now cyclic barrier we have initialized with 3, and here let's suppose a lot of oxygen threads comes here, so only 1 will be able to pass this point and it will be waiting here. So the moment the cyclic barrier is completed with the 3 threads, so it will call this thing release oxygen dot run. So this and this will be released by these calls, and then their permit, that semaphore permit will also be released. Then again the loop will go here, and since 2 thread have released the permit, then again 2 will be able to go through this point, and here we have initialized semaphore with 1 only, then again 1O will be able to pass this line, and then again it will wait. So this cycle will go on. Okay, so let's remove all these things, and let's see if this works. When stacked await cyclic barrier. Okay, looks good. So let's remove this package, and let us run it. Okay, so it is showing green, and now we can submit this. Okay, so this has this solution is accepted. So you can see here, beats 18% of user, whatever this is. Yeah, so this has been accepted. So basically we use 2 things: cyclic barrier, which means that you create a barrier, you kind of create a gate that with some value initial, and you say that until that number of threads arrive at that point, they all should wait. For example, here I initialized with 3. So until 3 threads arrive at that barrier point, maybe in different methods or classes, they all will wait. And the moment all will reach that cyclic barrier point, they all are released together. And semaphore means that only that many resources or permits or some clients can pass through that particular point. Okay.